DNN Models Case Study, ISO 21001 is an international standard developed by the International Organization for Standardization, ISO, specifically aimed at educational organizations. The standard provides a framework for management systems in education, ensuring that educational organizations deliver consistent, high-quality services that meet the needs of learners and other stakeholders. Pradeep K. Suri. Author, researcher, and AI/ML architect. DNN Models Case Study. The diagram illustrates the architecture of a deep neural network, DNN, a key concept in artificial intelligence and machine learning, specifically under the mentorship program attributed to Pradeep K. Suri. Explanation of the diagram. 1. General structure. The diagram represents a general DNN consisting of three main layers. Input layer represents the starting point of data entering the neural network. Hidden layer, S. Middle layer, S, where computations, weighted connections, and activations occur. Output layer represents the final outputs or predictions of the network. 2. Input layer. The circles on the left denote input neurons, which receive raw data, example features like age, salary, etc. Each arrow represents a connection from an input neuron to neurons in the next, hidden, layer. Input neurons are not computational, they only transmit data to the hidden layers. 3. Hidden layers, H1, H2, H3. The circles in the middle are hidden neurons organized into three layers, labeled as H1, H2, H3, H_1, H_2, H_3, H1, H2, H3. These layers apply weights to the inputs and pass the results through activation functions to capture nonlinear relationships. Arrows represent the fully connected structure, where each neuron in one layer is connected to every neuron in the next layer. 4. Output layer. The circles on the right are output neurons that provide the results after processing through the network. The number of output neurons corresponds to the desired outcomes, example a single output for regression tasks or multiple outputs for classification tasks. 5. Connections and weights. The arrows between neurons indicate weights WWW, which represent the importance of the connections. Each weight WWW is learned during training using optimization techniques like gradient descent. 6. Notes and mentorship attribution. The diagram is labeled Pradeep K. Suri, its association with the mentorship program. It also highlights the mentorship approach to simplifying the understanding of DNNs. Summary. This diagram serves as an introduction to the core concepts of deep neural networks, focusing on the three-layer structure and the flow of data. It helps beginners understand the foundational components of DNNs under the guidance of a structured mentorship program. The Deep Neural Network, DNN, diagram is foundational for developing various business applications. Below are examples of business use cases across different industries where such a DNN structure can be applied. ISO 21001 is an international standard developed by the International Organization for Standardization, ISO, specifically aimed at educational organizations. The standard provides a framework for management systems in education, ensuring that educational organizations deliver consistent, high-quality services that meet the needs of learners and other stakeholders. Key features of ISO 21001. 1. Learner-centric approach. Focuses on meeting the needs and expectations of learners, parents, teachers, and other stakeholders. 2. Improved educational processes. Ensures standardization and enhancement of processes like curriculum development, teaching methods, evaluation, and student engagement. 3. Accountability. Strengthens accountability for educational organizations by measuring and improving learning outcomes. 4. Inclusivity. Promotes equal access to education, accommodating learners with diverse needs. 5. Alignment with global standards. Helps align an organization's education management system with international quality principles. Applicable to. ISO 21001 is designed for all types of organizations in the education sector, such as schools, colleges, universities, vocational training institutions, corporate training providers. Business applications of ISO 21001. 1. Improved learning outcomes. Analyze and optimize teaching strategies using AI-driven performance metrics and personalized learning plans. 2. Educational process automation. Use AI and deep neural networks, DNNs, for automating admissions, assessments, and scheduling. 3. Stakeholder communication. Create frameworks for real-time feedback from students, parents, and staff. 4. Performance dashboards. Develop management dashboards that track key indicators like pass rates, dropout rates, and teacher performance. 5. Skill development and certification. Use DNN to recommend skill-based certifications for students based on career pathways. Business applications of ISO 21001. 1. Improved learning outcomes. Analyze and optimize teaching strategies using AI-driven performance metrics and personalized learning plans. 2. Educational process automation. Use AI and deep neural networks, DNNs, for automating admissions, assessments, and scheduling. 3. Stakeholder communication. Create frameworks for real-time feedback from students, parents, and staff. 4. Performance dashboards. Develop management dashboards that track key indicators like pass rates, dropout rates, and teacher performance. 5. Skill development and certification. Use DNN to recommend skill-based certifications for students based on career pathways. The video is a Sankey diagram illustrating the flow of elements within the AI model, ISO 21001 for schools and teachers, designed by Pradeep K. Suri. This diagram shows the relationships and interactions between different components of the educational system. Let's break it down. Components of the diagram. 1. Schools. Representation, the starting point, depicted by 3 colored flows, green, cyan, and red. Function, schools are the primary sources that influence both students and teachers. 2. Students. Flow, students receive inputs from schools and are divided into 3 parts. Classroom activities, part of the student's flow goes into classroom activities. Extracurricular activities, another part goes into extracurricular activities. Examinations, the last part goes into examinations. 3. Teachers. Flow, teachers also receive inputs from schools and are divided into classroom activities, teachers contribute to classroom activities. Extracurricular activities, teachers engage in extracurricular activities. Examinations, teachers are involved in examinations. 4. Classroom activities. Inputs, receives inputs from both students and teachers. Outcome, leads to performance improvement. 5. Extracurricular activities. Inputs, receives inputs from both students and teachers. Outcome, leads to skill development. 6. Examinations. Inputs, receives inputs from both students and teachers. Outcome, leads to knowledge retention. 7. Performance improvement. Source, the outcome of classroom activities. 8. Skill development. Source, the outcome of extracurricular activities. 9. Knowledge retention. Source, the outcome of examinations. Insights and implications. Interconnectedness, the diagram visually represents the interconnectedness of various elements in the educational system, highlighting how schools, students, and teachers contribute to different activities and outcomes. Flow representation, the flows illustrate how inputs from schools influence both students and teachers, leading to various activities and educational outcomes. Outcomes, the diagram emphasizes the importance of classroom activities, extracurricular activities, and examinations in achieving performance improvement, skill development, and knowledge retention. Summary. This Sankey diagram provides a clear visualization of the relationships and interactions within the educational system under the AI model, ISO 21001 for schools and teachers. It highlights how different components, such as schools, students, and teachers, are interconnected and how their activities lead to important educational outcomes. Detailed explanation of the 3D plot, AI 3D model ISO 21001 for schools and teachers. The video titled AI 3D model, ISO 21001, Schools and Teachers, Architect, Pradeep K. Suri presents a 3D visualization. Let's break it down. Axes and dimensions. One x-axis represents one dimension of the data, potentially time, geographic location, or another variable related to schools and teachers. Two y-axis represents another dimension of the data, possibly a metric like performance, engagement, or resource allocation. 3 z-axis represents a third dimension, could be a measure like funding, student-teacher ratio, or achievement levels. Points and lines. Points, different points in the 3D space, color-coded according to their value on a particular metric. Color intensity scale, on the right, the color intensity ranges from 0, purple, to 1, yellow, indicating the varying levels of a specific variable. Points closer to yellow have higher values, and those nearer to purple have lower values. Lines, orange connecting the points, these lines represent the relationships or transitions between different data points, showing how they are interconnected in the 3D space. Interpretation of the 3D model. Purpose, this model likely visualizes complex data relationships within the educational context of schools and teachers as defined by ISO 21001 standards. Applications, could be used to identify trends, correlations, and patterns in educational data, helping educators, administrators, and policymakers to make data-driven decisions. Potential insights. Trend analysis, by observing the distribution and connections of points, one can infer how different variables interact over time or across different settings. Performance metrics, the color intensity scale helps in quickly identifying high and low values of a particular metric, aiding in pinpointing areas of success or concern. Resource allocation, understanding the 3D relationships may provide insights into where resources are most effectively used and where improvements can be made. This 3D plot is an effective tool for visualizing multidimensional data, making complex relationships more accessible and understandable. How the 3D AI model can help schools and teachers. The 3D AI model, based on ISO 21001 standards for educational organizations, provides a comprehensive and visual approach to managing and improving various aspects of the educational process. Here's how it can be particularly beneficial for schools and teachers. 1. Enhanced data analysis and visualization. Understanding complex relationships, the 3D model allows schools and teachers to visualize complex relationships between various educational metrics, such as student performance, teacher effectiveness, and resource allocation. Identifying trends and patterns, by analyzing the spatial relationships and color intensity, educators can identify trends and patterns that might not be apparent in traditional 2D charts. This helps in understanding the dynamics of the educational environment. 2. Performance monitoring and improvement. Tracking progress, schools can use the model to track the progress of students and teachers over time. This helps in identifying areas where students excel or struggle, and where teachers can improve their teaching methods. Setting targets, the visualization can help set realistic and achievable targets for both students and teachers by providing a clear view of their current performance levels. 3. Resource allocation and optimization. Efficient resource use, the model can highlight areas where resources are well utilized and areas that need more attention. This ensures that schools can allocate their resources efficiently to maximize their impact. Budget planning, understanding the resource needs of different departments or classes can help in effective budget planning and ensuring that funds are directed where they are most needed. 4. Personalized education and support. Tailored interventions, by identifying students who need additional support, teachers can provide personalized interventions to help them succeed. Professional development, teachers can use the insights from the model to identify areas for their professional development, focusing on skills and knowledge that will have the most significant impact on their teaching effectiveness. 5. Policy making and strategic planning. Informed decisions, administrators can use the model to make informed decisions about school policies and strategic planning. This ensures that decisions are based on data and real insights rather than assumptions. Long-term planning, the model helps in understanding long-term trends, which is essential for strategic planning and ensuring that schools are prepared for future challenges and opportunities. Practical applications. 1. Curriculum development, by understanding which teaching methods and materials are most effective, schools can develop a more impactful curriculum. 2. Teacher evaluations. Regular assessments of teacher performance can be visualized to provide constructive feedback and encourage continuous improvement. 3. Student counseling. Counselors can identify students at risk of falling behind and provide timely support and guidance. 4. Parental engagement. Schools can share insights from the model with parents to keep them informed about their child's progress and how they can support their education at home. Summary. The 3D AI model based on ISO 21001 standards offers a powerful tool for schools and teachers to enhance their educational processes. By providing a detailed and interactive visualization of critical metrics, it helps in data-driven decision-making, personalized education, efficient resource allocation, and continuous improvement in both teaching and learning. Thank you.